In this video, we're going to be solving rational inequalities. So as with quadratic and polynomial inequalities, we're going to use those same concepts of finding critical values and test intervals that can be drawn on a number line to find out the solutions for the rational inequality. So when we see a rational expression, we have a numerator and denominator, and a rational expression can change the sign only at the zeros in the numerator and the undefined values from the vertical asymptotes and wholes in the denominator. So these are the numbers that are going to make up our critical numbers of our rational inequality. When I see this first example, the main thing that we need to do with an inequality that's different than when we're solving equations is that we need to get this equal to 0. So I'm going to get everything on the left and 0 on the right. I do that by subtracting 3. So I have my rational expression minus 3. And it's less than or equal to 0 now. When we are trying to combine rational expressions, anytime you think back to adding or subtracting fractions, you needed a common denominator. So that's a new concept for us, is finding a common denominator between these. Right now, the denominator of 3 is just 1. So to get a common denominator, we're multiplying by x minus 5 over x minus 5. And I think using a separate color for that just shows that you're multiplying and getting the common denominator. It's going to help you as we get to some more complicated denominators. But now that we have a common denominator, we can combine them. So I would have 2x minus 7 minus 3 times x minus 5 all over x minus 5. When I distribute, I get negative 3x and a positive 15 all over x minus 5. So far what we did, just to kind of clarify and add some explanation, we started out by getting everything on the left. So we get everything on one side. Then we needed a common denominator, so we can find a common denominator that way we can combine our fractions. We went ahead and combined and we simplified. But now that we've got it all the way, we're going to combine, we want to simplify our expression. So negative 2x and negative 3x is going to be negative 1x. Negative 7 plus 15 is a positive 8 over x minus 5. We can't do anything else to this expression. So it's simplified as much as we can, but we still need to find our critical values. So we're going to get our critical numbers from the x-intercepts in the numerator and the vertical asymptotes in the denominator. And we may have more than one x-intercept on top. We may have more than one vertical asymptote in the denominator. For this one, we luckily just have one of each. So when I look at the top, negative x plus 8 can equal 0 if we solve it out and I get negative x equals negative 8. So divided by negative 1, I get a positive 8. So when x equals 8, that's one critical value. And we have this other one from the denominator. Remember, denominators cannot equal 0. So what we're saying is x minus 5 cannot equal 0. x cannot equal positive 5. This is that vertical asymptote, or it's creating the vertical asymptote. So the vertical asymptote will always be an open circle on our number line. So that becomes an open circle on the number line because it is an excluded x value. So let's create that number line that we have here. So this would be a 5 and then an 8. All right, so our 5 is going to be an open circle automatically, but we don't know about this 8. Okay, so when I think about the inequality symbol, it was less than or equal to 0. The 8 is when it would equal 0, so we can fill that in. I'm just going to write a little note here about that. So x equals 8 is closed because our inequality sign has the equal to. If it had been strictly less than 0, we would have had an open circle at 8 as well. But your denominator pieces will always be open no matter what, because those are our excluded x values. Now we're kind of back to what's familiar with this number line and finding the sign analysis. So we've gotten 3 different test intervals. From negative infinity to 5, from 5 to 8, and then 8 to infinity. And we just pick different values in between. So let's pick something to the left of 5, like we can even do 3. If I plug that in, let's say negative 3 plus 8 over negative 3 minus 5. We get a positive on top and a negative on bottom. That's always going to come out to be a negative value. Then we plug a number in between 5 and 8, like 6. So negative 6 plus 8 over 6 minus 5. I just realized I'm putting negative here. That wasn't supposed to be there, but 3 minus 5 is still negative. So 6 minus 5 is positive on bottom this time, and we have a positive on top. That gives us a positive in the middle. We pick a value in to the right of 8, like 9. So negative 9 plus 8 over 9 minus 5. Gives me a negative on top and a positive on bottom, which is negative. So when I'm finding all the solutions for this, we want the values that are less than 0, less than or equal to. That's going to be to the left of 5 and to the right of 8. And we write out our solution interval in interval notation. So that solution would say negative infinity to 5 union, and then a bracket at 8 to infinity. Okay, so we have 2 more here. You can pause the video and try them out on your own. If you want, just use the same logic that we had with the first one. For number 2, I would subtract everything over to get this equal to 0. So that would be x over 2 minus 5 over x plus 1 minus 4 is greater than or equal to 0. This one's a little bit trickier to get a common denominator. So what I do with this, I'm just going to rewrite this with our denominators again. Okay, so if I look at each denominator, I'm looking to see what does this have and what does it not have. This has a 2, but the other denominators had an x plus 1. So this is missing an x plus 1 factor. So I'm going to put that on bottom. But if I multiplied it on bottom, I need to multiply it on top so that we have a balanced fraction. The second fraction has an x plus 1, but it's missing a 2. So I would take that and multiply by 2 on top and bottom. The last one is missing a 2 and an x plus 1, so I multiply by 2 and x plus 1. So times 2 times x plus 1. And now we just work out the algebra for this. So this first one's going to say x squared plus x minus 10 over 2 times x plus 1. Minus, and then this, I can just do 8 times x plus 1, or you could go ahead and distribute your 8. Either way, that's fine. If you had distributed, let me just rewrite this one more time. You'd have 8x plus 8 on top. And this is where I see students make mistakes, because we are subtracting that whole fraction. So you're going to be subtracting 8x and the 8. So you need to make sure that you're distributing your subtraction. So I'm just going to combine all of this together on top. X squared plus x minus 10 minus 8x and minus an 8. So that whole thing is going to be subtracted. All right, over 2 times x plus 1. If I simplify it, I get down to x squared minus 7x minus 18. So we did all this work just to get it equal to 0 and down to one fraction, but we still want to factor it because I'm trying to find out the x-intercepts in the numerator. So if I factor, I get x minus 9 times x plus 2. Over 2 times x plus 1. It's greater than or equal to 0. Now I can solve for those critical values. So x minus 9 equals 0. X plus 2 equals 0. These are the x-intercepts. But then we also had our denominator, which created our vertical asymptotes. So 2 is not going to really be a vertical asymptote. It's just a scalar. It's multiplying to the factor of x plus 1. So the x plus 1 is what would create that vertical asymptote at -1. The x-intercepts were at 9 and -2. So I'm going to put this in my number line. And remember, we're doing it when it's greater than or equal to 0. So I find those numbers, -2, -1, and 9. But -1 is an automatic open circle. I don't even have to think about the inequality sign because that's coming from the denominator. The x-intercepts, we do have to consider this inequality symbol. We have an equal to, which means that those get to be closed in. And then I just test out these intervals. So I pick a number to the left of -2, like -3, and we're plugging this into our fraction. -3 minus 9 is going to be negative. -3 plus 2 is also negative. Divided by 2 times -3 plus 1, which is still negative. And I'm including the 2 there because if that had been a -2, that would impact our sign as well. So we just keep that value there. A negative times a negative is a positive, and a positive divided by a negative ends up being negative. So that's what's happening to the left of negative 2. Then we pick a value in between negative 2 and 1, negative 1. This you might have to put negative 1.5. If you need to use a calculator, that's fine. Think about this would be parentheses negative 1.5 minus 9, and you can do it that way. But you should get a negative here, and then negative 1.5 plus 2 comes to positive, divided by 2 times negative 1.5 plus 1 is still negative. So we get a negative divided by a negative, which is positive. A number between negative 1 and 9 is 0. So if I plug that in, I should get a negative times a positive divided by 2 times a positive, which is negative. And then lastly, a number to the right of 9, so maybe 10. 10 minus 9 is positive, 10 plus 2 is positive, and 2 times 10 plus 1 is still positive. So that whole thing comes out as positive. Since we're looking for when it's greater than or equal to 0, the positives would be shaded, and then we turn that into our interval solution. So this would say bracket negative 2 all the way to negative 1 with a parenthesis, union bracket 9 to infinity. Okay, and for number 3, we have to factor it even though it's already equal to 0. So I take that numerator and we try to factor as much as we can. So I can pull out a GCF because x cubed, x squared, and x all have an x in common. Leaves me with x squared plus 10x plus 25 divided by, and then x squared minus 4 is a difference of 2 squares, so I can make that x plus 2 times x minus 2. But the numerator is not done. It can still factor. So x times, and then we work that out. So x squared came from x times x. Factors of 25 are 5 and 5. And then we need them to combine to give me a 10. So x plus 5 times x plus 5. Okay. You could have rewritten this as x times x plus 5 squared. That would be fine. Either one of these would work when you're trying to actually find your critical values. So these critical values are coming from the x-intercepts and our denominator. Okay, so our x-intercepts would be x equals 0 and x plus 5 equals 0. The denominator would say x plus 2 cannot equal 0 and x minus 2 cannot equal 0. So we work it out. The first one, there's nothing to do. It's just x equals 0. The second one, x equals negative 5. This one says x cannot equal negative 2. And this one's x cannot equal positive 2. So I'm going to put all of those on my number line. And it's still less than 0 is what we're looking for. If I find negative 5 first, then negative 2, 0, and positive 2. These in the denominator are automatically open circle. So open at negative 2 and open at positive 2. We have to consider what's going on here at negative 5 and what's going on at 0 based off of this inequality symbol. Since it doesn't have the equal to, that's still going to be open and open. Now we just do all these test intervals, and we have a little bit more than what we're used to doing, but let's test them out. So pick a value to the left of -5, like -6, and you plug it in. You can use your calculator if you need to. You have -6 times -6 plus 5 squared over -6 plus 2 times -6 minus 2. I get a negative value. We're not really worried about what that number is, but we do end up with a negative. Then we pick a number between -5 and -2. That could be like -3. We do the same thing, plug it back in, so -3 times, oops, let me get the fraction button, -3 times -3 plus 5 squared over -3 plus 2 and -3 minus 2. Gives me a negative again. Pick a number between -2 and 0. So maybe -1. -1 times -1 plus 5 squared, -1 plus 2 times -1 minus 2. Gives me a positive this time. Pick a number between 0 and 2, like +1. So 1 times 1 plus 5 squared over 1 plus 2 times 1 minus 2 is negative. And then the value to the right of 2 would be like 3. So last one, 3 times 3 plus 5 squared over 3 plus 2 times 3 minus 2 comes out positive. And after looking at all those signs analysis, we're looking for when it's less than 0. Here's a negative. We have to skip over -5. This second interval here is also negative. And then we had another one here. So this solution region will come out to be -infinity all the way to -5, excluding -5, union, then -5 to -2, union, 0 to 2. All right, so try the rest of these that are in the lab manual for some practice.